In this video, we're going to look at how you can use algebra tiles to illustrate the steps to solve an equation. For instance, like this one here, 2x plus 6 equals negative x minus 3. The first thing I'm going to do is to set up this space where I'm going to put the algebra tiles to show that I mean to be representing an equation. So I'm going to put a little piece of paper in the center with an equal symbol on it, so that when I put some algebra tiles on the left and some algebra tiles on the right, it will kind of cue me that I'm intending to consider those two collections to be equal. I'm not just adding them or doing something else with them. The second thing I'm going to do in a preliminary sense here is to reinterpret this last term here where it says minus 3. I don't really want to be trying to take away 3 before I even get my equation represented. I want to be looking at a collection that means the same thing. So I'm going to be thinking of this right-hand side as negative x plus a negative 3. The left-hand side will stay the same. But that's how I'm going to represent this equation. On the left-hand side, I'm going to be using these rectangle algebra tiles as my x pieces. That's typically how we've interpreted them when we've been doing multiplication and factoring and those kinds of texts. We often think about this 1 by 1 squares, so they each have an area of 1. I'm going to put out 6 of those to represent the plus 6. Then on the right-hand side, I want to show negative x, so I'm going to put one of those long rectangles, but with the red side facing up to make it negative, plus a negative 3. So here is my negative 3 1 pieces. So this is my initial setup. 2x plus 6 equals negative x plus a negative 3. Now I'm permitted to do legal moves such as add the same thing to both sides, or take away 0 pairs, or remove the same amount from each side. Those same kinds of moves that we could do when we were using the balance, they're basically the same moves that I'm going to do with the algebra tiles. And as I do those moves, I'm going to keep track of how I would write each step on a pencil paper or chalkboard, that algorithm, so that I see the connection between what I'm doing with the algebra tiles and what I would do on paper and pencil. So the first step I might do is to add x to both sides. If I do that, and of course on the right hand side I'm going to get a sum of 0, which is the same as a 0 pair. Let's do it. So here I'm adding x to both sides. It's a legal move. I've added the same amount to both sides of my equation, and I see I have a 0 pair. So I'm going to just pick that up and remove it, since it's just 0. It doesn't change the quantity. And that gives me, as I can see, 3x plus 6 on the left equals negative 3. The next thing I will do is I'd like to either subtract 6 or add a negative 6. It's going to be simpler to add a negative 6 to both sides because I don't have any positives on the right hand side to subtract from. So let's do that. Plus a negative 6 plus a negative 6 on both sides. So let me get my tiles. Put these negative 6 tiles on each side. Okay, and there again, I still have a balanced equation because I added the same amount to both sides. Of course, there's some simplification that can happen on the left here. I have a bunch of 0 pairs, and so I'm going to just scoop them all up and get rid of them. In the paper pencil, the 0 pairs are this right here, +6 plus a -6, sums to 0. So I just have 3x left. On the right hand side, I can see I now have a -9. Okay, now for my last step, I have 3 copies of my unknown x, and I have a pile of negatives over here. I want to think about the meaning of division. I'd like to know how many of these tiles correspond to just one of the x tiles. So I make 3 equals to x. I've got 3 x's, so I need to make 3 equal groups of the ones tiles, the little -1 tiles on the right. And that can clarify that each x is equal to -3. So that's how I illustrate that step in the tiles. And of course, on paper, we would write something like this. So that's how we use the algebra tile to represent an equation. Notice that in contrast to the 4-pan balance, this model allows the unknown to be a negative number. Okay, that's partly because we're using a little bit more abstract way of representing negatives here. Negatives don't have to actually physically make the balance lighter, so we can just match these up. Also notice again, just like the 4-pan balance, representing that final division step, we basically had to think about the meaning of division and make equal groups. And then finally, also like the balance, we need to keep track alongside of the actions with the tiles. We need to keep track of what it would look like on paper and pencil so that the students connect those two things, the actions with the tiles and how we keep a written record.